Here we'll talk about centripetal force. We are already familiar with the concept of centripetal acceleration. So that was done as part of kinematics. See, an object is moving in a circular path with some angular speed omega and tangential speed v. Now this object is moving in a circular path. There is an acceleration component of this object towards the center, right? That acceleration is called the centripetal acceleration. When there is acceleration, so there must be a force, because without force there is no acceleration. So the force acting on this object towards the center, so that is called the centripetal force, or the force which causes the acceleration. Centripetal acceleration is called the centripetal force. Suppose this force was not there, then what will happen? The velocity of the object will not change, right? When there is no force, the velocity of the object will not change. The object will move in a straight line path only. It will not move in a circular path. Its direction changes. Direction changes, that means the velocity changes. The change in velocity is because of a force. Without force, there is no change in velocity. So that which changes the direction of this object is the centripetal force that acts towards the center of the circle. Okay, so this force is called centripetal force. We are already familiar with centripetal acceleration. So acceleration, force, we know the relation. So the same formula we are going to use here. What is the formula for centripetal acceleration? So that as formula, centripetal acceleration. So that formula we are already familiar with, like that has formula, the acceleration, the centripetal acceleration equals, so v square divided by r, right? So that is the formula for centripetal acceleration in terms of the tangential speed. Or if you write this formula in terms of the angular speed, so that is r omega square, right? So this formula we are already familiar with. Okay, when you know the acceleration, we can find the force. So centripetal acceleration, so we know. So now we have the formula for centripetal force then. So the centripetal force is simply mass times the acceleration. So acceleration is already known, multiplied by the mass. So mv square divided by r. So that is the force, right? Centripetal force. Or if you use this formula, it is mr omega square. So that's all. So that is the formula for centripetal force. Okay, yes. If an object is moving in a circular path, there is a force acting on that object towards the center of the circle. So that force is given by this formula, mv square by r, or mr omega square, so which is called by the name centripetal force. Okay, yes, that's all. Now this centripetal force is not a separate force like a gravitational force or normal reaction. No, it is just certain behavior of any force, right? This centripetal force can be due to any other force, right? For example, so this object is like whirled in a circle, right? Now this object moves in a circular path because of the tension force, right? The tension due to that string. The tension is what is keeping this object from flying away, right? If this tension was not there, right? If you cut this string, no tension, that means this object will move in a straight line path, right? It will move in the tangential path. So because of the tension force, this object is moving in a circular path, right? So that means the tension behaves as a centripetal force here, right? So the tension can be centripetal force, right? Similarly, the gravitation force can be the centripetal force, right? Yes, now the gravitation force, so the moon is revolving around this planet Earth because of the centripetal force, right? That centripetal force here is due to the gravitational force by the planet. You understand? So gravitational force can be centripetal force. So centripetal force is not a separate force. It is certain behavior of the force, right? If a force behaves in a certain way, it is called a centripetal force, right? If the force creates that circular effect, right? So it makes the object moves in a circular path, then we call that force the centripetal force. That's all. Alright. So centripetal force can be any force depending upon the context. But if the force behaves like the centripetal force, then it has formula this one, right? mv square divided by r, right? So that's all. So let us use this formula of centripetal force to do some questions. Okay. Here an object attached to a spring is rotating in a circular path, circular motion. That means there must be some centripetal force. But what is the centripetal force here? See, here this object is rotating in a circle because of the spring force. If the spring force was not there, this object will move away from that circular orbit. See, the spring force is what is keeping this object in that circular orbit. That means this spring force behaves as the centripetal force here. So the centripetal force here is same as the spring force. Alright, yes. So find the formula, use the formula for the spring force and also centripetal force. So these two are equal here, right? So the spring force, so the spring force here is same as the centripetal force here. Okay, centripetal force. So what is the formula for spring force? So that is K multiplied by that elongation, right? So Kx. Okay, so that must be equal to the centripetal force. What is the formula for centripetal force? So here the angular speed is given, right? Angular speed is omega. That means we know the formula, right? In terms of the angular speed. So m r omega square. So that is m r omega square. But what is r? Radius of that circle. Not L. L is the length of the spring, the original length of the spring. But so now there is some elongation, right? So now L plus x is the total length, right? So that is the radius of the circle. So that is L plus x. Okay, m r omega square. Okay, so that's all. From this you have to find the value of x. So that is the elongation of the spring. Okay, so find it. So bring it to one side. So that is kx minus, so m omega square x equals m l omega square. Okay, so that's all. So that will give you a required value of x. From this you can take x out. So that is x equal to, that is m l omega square divided by, so this value, right? So k minus m omega square. So that's all. So that is the value of x, which is the elongation of the spring. Alright, so very simple. So in depending upon the context, different forces may behave as the centripetal force. So centripetal force formula is known, and we already know that the centripetal force is the spring force. Spring force is also known. So these two are equal. From that we can find the value of x. Okay. This time the sphere is moving in a vertical circle. So that means we have to consider the gravitational force also. In the last case, that was a horizontal circle. Gravitation force is perpendicular to that tension force, right? So that means we didn't consider the gravitational force for the centripetal force. But here, the gravitation force also will contribute to the centripetal force. So at which point the tension will be maximum? So we don't know, so we take a general point, okay? But you can easily guess at the lowermost point only the tension will be maximum. But anyway, we'll take the most general case. Suppose the string makes some angle theta with the vertical, okay? At that point, let us find the tension. So what is the centripetal force here? So the centripetal force here is due to, so what is meant by centripetal force? The force that acts towards the center of the circle. So but here that force can be due to the tension force and also the gravitation force. See at that position, what is the force acting towards the center? The tension force. Towards the center, tension. So centripetal force. So that has formula mv square divided by that L. Okay, mv square by L. Okay, so that is the centripetal force, and that is equal to here what is the centripetal force? The tension force towards the center, right? Tension force, so T. Okay, yes, so tension force. And also the gravitational force, not the gravitational force but only the component mg in the downward direction, that makes what angle with that normal direction? So that is theta, which means mg cos theta in the opposite direction. Remember, not towards the center but away from the center. So that means mg cos theta, right? Its component in that direction of the radial direction. So that is minus that. So minus mg cos theta. So that's all. So this is the centripetal force, that is same as here the tension and the gravitational force, right? The component of the gravitational force. From that we can find tension. That's it. So the tension here is equal to, so the tension is equal to here mv square by L plus mg cos theta. Okay, so that's it. So this is the tension at some random point, okay, where when this string makes angle theta with the vertical. But we want to find the maximum tension. So what is the maximum tension? So that is obvious right here, because all other values are constant. Remember, m, v, l, all these are constant. Only variable is theta. Okay, theta can be different at different points. So these are all constant. You write it mv square divided by L plus mg multiplied by maximum value of cos theta. So that is 1, right? So cos theta is maximum 1. because we know that cos theta lies between these values, right? -1 and 1. The maximum value of cos theta is 1. That's all. So this is the maximum value of the tension. That's it. But that happens when the value of theta is equal to 0, right? Because cos 0 is 1. So that is the maximum value. So theta is 0 means what? So when the string is vertically down like this, okay, that means the angle theta is 0, only then the tension is maximum. Similarly, minimum can be found. Minimum of this is -1. So that is when theta is 180 degree. That means it is the topmost point. Okay, so this sphere is at the topmost point. That is when it will have minimum tension. So the maximum tension is when it is at the bottommost point. So this is the value of maximum tension. Do you understand? So but L is given in the question, right? L is 1 meter, right? So that means we can substitute here. So mv square plus mg, right? So mg is the length, sorry, L is the length of the string. So that is given to be 1 meter. So that's all. So this is the maximum tension of the string. Okay. Here also we have a pendulum, but conical pendulum, right? So it is moving in a circular path, horizontal circle only, but tension is acting in a different direction, not towards the center, right? So we have to take its component, that's all, right? The same idea. So first of all, we will consider all the forces acting on this object in the vertical direction. What are the forces acting on in the vertical direction? So the component of t in the vertical direction, right? So t is in this direction. Now we have to take its a component, right? So theta, right? Same alternate angle. T cos theta in the vertical direction, upward direction. T cos theta. Minus in the downward direction we have that weight, that is mg. Okay, that's it. So this is in the vertical direction. So that will give you t value, right? If required, we can write t value. Okay. Now the centripetal force. The centripetal force. So what is centripetal force here? That is the force acting towards the center. That is only the component of t, right? In that direction. See, t, that is 90 minus theta, theta 90 minus theta. So that is t sin theta. Okay, that is towards the center. So centripetal force has formula mv square divided by r. That equals, that is t sin theta. T sin theta. Okay, so that's all. So this t can be substituted from this, and then we'll get v, right? What we want is the value of v, that's all. So it is m v square divided by r. So that equals t. T can be substituted from this. So mg divided by cos theta multiplied by sin theta. So that's all. So this will give you the value of v, right? So find the value of v. M gets cancelled. So this is v square is equal to gr tan theta. So that is the value of v square. Okay, but we don't know the value of tan theta, right? Theta is not known, but you can find tan theta, right? It is a right angle triangle, so we can find the value of tan theta. See, we know sin theta. In that right angle triangle, what is sin theta? So that is opposite side, right? So that is the base. Base is the radius divided by the hypotenuse, which is the length of the r by l, right? So that is the base divided by, right? That is the opposite side divided by the hypotenuse. Okay, done. Now from that we can find tan theta also. So what is tan theta? That is opposite side divided by the adjacent side, which is, you can use the Pythagoras theorem to find, right? The square root of l square minus r square. That's all. That is the value of tan theta. That can be substituted here. Okay, so that will give you our v value. So we can take square root also after substituting grr, right? R square, that means r square root of g divided by again root of l square minus r square. See, these values are given in the question, right? So l is given, the length of the string, so that is given to be 10, right? 10 square minus r square, right? R is also known, which is 6. Okay, so you just substitute these values here. R is 6, square root of g value, because all other values are known. Let's take the value of g to be 10. The square root of, okay, let me write it, square root of, this is l square, which is 10 square, 100 minus that is 6 square, 36. That means 8. Okay, 64. So square root of, okay, so that is 64. So this is 10 divided by 8. So that if you simplify, we will get the value of the square root of 5 divided by 4. Right, that is 2. So that is 3 root 5. That's it. Just calculation. So nothing. different. Okay, so that's all. So that is the answer, right? So 6 divided by 2, so that is 3 root 5. Okay, that's all. So 3 root 5 is the value of v. All right, so that is the speed of, that means the tangential speed of that the sphere. Okay, so that is the answer. Here a block is placed at a distance x from the center of a rotating disc. Now this block should not slide. That means there is no relative motion between this block and the disc. That means friction acts as the centripetal force. If this friction was not there, this object will move outward, right? So it will move away from that circular path, right? It will be outward motion, but that is prevented by this friction. So friction is the centripetal force here, right? So what type of friction? There is no relative motion. That means the friction here is the static friction, right? Maximum friction, if you calculate, that is the kinetic friction or limiting friction here. So here there is no slipping. That means it is a static friction. So the friction acts as the centripetal force. Okay, yes. So that means the centripetal force here. So the centripetal force here is due to the frictional force. What is the centripetal force formula? So that is the same formula, mv square divided by the radius, but radius is x, right? So the distance of that block from the center, that is the radius of that circular path, so that is x. Okay, that must be equal to the frictional force. Okay, yes, frictional force. But which type of friction? It is the static friction. Static friction. Okay, because no relative motion, so static friction. But static friction should be less than or equal to that kinetic friction or limiting friction, right? Both are same because just mu. So this f must be less than equal to, so mv square divided by x must be less than or equal to the limiting friction, right? Limiting friction, because static friction is less than or equal to the limiting friction, right? So that means you can use the formula for limiting friction. So that is mu mg, right? M multiplied by g. So that's all. So mv square divided by x is less than or equal to mu mg. That's it. That will give you our required mu. So this gives you the value of mu. If this is greater than or equal to, what do you get? So m gets cancelled. So this is v square divided by gx. That's also, that is the answer. Mu has to be minimum this value, v square divided by gx. So mu is greater than or equal to 3. If mu is greater than that value, v square by gx, this block will not slide. Okay, otherwise it will move away. Okay, so it will not stay in that circular path, right? The friction is very less. If this mu is at least minimum v square by gx, only then it will move in the circular path. So that is the required answer. Okay. This is a simple question. Here the centripetal force is due to the component of the tension force, right? Tension in that string. So take the component, right? We need to find the radius also. So directly use the formula. So the centripetal force here is due to the tension force, the component of the tension force in the horizontal direction. Now we consider the vertical direction. What are the forces acting in the vertical direction? So the component of the tension in the vertical direction, tension is in this direction, take the component, so that is theta, right? Same theta, so t cos theta in the vertically upward direction, t cos theta. Similarly in the downward direction we have the weight mg, so that equals 0. Okay, no vertical motion. Okay, so that is vertical. Now the centripetal force, okay, in the horizontal direction. What are the forces acting in the horizontal direction? Centripetal force. See, what is the formula for centripetal force? So m r omega square. Omega is known, right? The angular speed. So m r omega square. But what is r? So that you have to find. Okay. So that you have to find, directly not known. So r is the total radius, right? From that post to that object, right? So what is the distance? That is L plus the component of that L. L is the length of the string also here. So what is its length? So that angle is theta. That means the opposite side is L sin theta, right? L plus L sin theta, that is the total radius. L plus L sin theta, that is the radius. The radius means what? That object is at a distance L plus L sin theta from that axis of that circular path, right? Yes, L plus L sin theta. M r omega square. Okay. That is the formula for the centripetal force. That centripetal force here is due to the component of tension force in that horizontal direction. That is T sin theta, right? 90 minus theta, so T sin theta. So this is due to that, T sin theta. So that's it. So we have to simplify and get the value. All right, yes. So that's all. So let us find this by simplifying this. So here M L, it is 1 plus sin theta and then omega square. So that equals T. But T value is what? Mg divided by cos theta. So instead of T, we can substitute that Mg divided by cos theta. So we can write it as tan theta, right? Because sin theta divided by cos theta. So that is tan theta. So now we want to find this omega, right? So let us find omega by simplifying. The M gets cancelled. So we are getting omega equal to, so G gets cancelled. So it is, M gets cancelled. So G tan theta divided by, so G tan theta divided by, this is L multiplied by 1 plus sin theta. So L multiplied by 1 plus sin theta. Okay, so this is the value of omega, that is the angular speed, omega square it is. Now we have to take the square root. Okay, so that's also, that is the answer. G tan theta divided by L multiplied by 1 plus sin theta. That is the value of the angular speed omega. Okay. Here we have a projectile. A ball is projected at certain angle theta with a horizontal with some speed u, right? Initial speed is u with some angle theta, right? Now we have to find the radius of curvature when the velocity makes angle theta by 2 with the horizontal. What is radius of curvature? See, this is not a circle. So there is no radius, right? It is not a circular path. It's a projectile, so it is a parabolic path. So no curvature, no radius, right? Because only for circular path we talk about radius. But for small value, right, small length of that curve, it can be approximated to be a circle, right? So that curvature can be taken as part of a circle. So the radius of that circle we have to find. Okay. Now this is not moving in a circular path, but it is moving in a parabolic path. But for very small values, it can be approximated to be a circle. You have to find the radius of that circle at that point. Okay. Yes. Now what is centripetal force now? If you approximate this to be a circular path, so it is there is a centripetal force. So centripetal force is the only force acting on this object is the gravitational force, but you have to take its component in the direction towards the center. Okay, mg cos theta by 2, right? Same angle theta by 2, mg cos theta by 2. So that is the centripetal force. So centripetal force. So that's all. Use the formula for centripetal force. Equate that to the component of the gravitational force. Okay, and one more thing, the gravitational force is the only force acting on the object, and that too in the vertically downward direction. No force in the horizontal direction. That means the velocity component of this object in the horizontal direction remains same wherever the point is. At any point you find the velocity of the object in the horizontal direction, that will have the same value because there is no force to change the velocity. What is the initial velocity component? The velocity component in the horizontal direction. So we will find a velocity component in the horizontal direction. What is initially u cos theta, right? U is the initial speed, so that is theta, so u cos theta, that is the initial component. Okay, u cos theta. And at that point, at that required point, so the velocity is taken as v, right? V is the speed, take its component v cos theta by 2. So that is v cos theta by 2. So that's also, we got a relation between this u and v. Okay, we can use it later. Now let us find the centripetal force here. Centripetal force. So what is the centripetal force here? The formula, so that is m v square divided by r. R is the radius of the circle, and that is what we call by the name radius of curvature. So what we need to find is this r. But the centripetal force here is due to the component of the gravitation force in the direction towards the center. That means mg component, so cos theta by 2. mg cos theta by 2. Okay, that's all. So this you can solve to get the value of okay, r is what is required in the question. So m gets cancelled. So and also we have to substitute this. V is not known in the question, right? So you have to substitute the value of v from this. Okay, so what do you get? yeah, m gets cancelled, v square. What is v square? So it is u square cos square theta divided by, this is cos squared theta by 2. So that equals, if you multiply r multiplied by m is cancelled, g cos theta by 2. Okay, so that will give you our required value of r. So r is equal to this value of r, right? So that is simply, yeah, divide it. So this is u square cos square theta divided by, so if you divide it, so we get g, and cos square theta by 2, again we have cos theta by 2, so that means we have cos cube theta by 2. So that's it. So that is the required r, which is the radius of that circle. So that is called the radius of curvature. So the radius of the curvature, it may be different at different points. Okay, we are finding the radius of curvature at that particular point. Okay, so then the, yeah, so that has radius of curvature r, which is u square cos square theta divided by g cos cube theta by 2. Here a block is moving in an uneven path but with the same speed v, right? Here, see, this is a curved path, right? So we can approximately take this to be a circle, not for all values but for some small distance, right? For small distance at the topmost point, so we can use the concept of radius of curvature. So that small curvature, that can be taken as part of a circle of radius, say r1. Similarly, the other point b, so we have a circle radius r2, but this is a bigger circle, right? R1 is bigger than r2, right? So there the curvature is very less, right? Like, so the radius of curvature is less than the radius of curvature here. The other part, right, at point c, there is no curvature, right? C, it is a horizontal path only. We don't need to use the concept of radius of curvature, but for the other two, they are not horizontal, so curved path. So we take it to be approximately a circle. Okay, now what you do? We have to take the normal reaction. When there is a circular path or approximately a circular path, we can use the concept of centripetal force. Alright, yes. Now at the point A, at the point say A, what are the forces acting towards the center of the circle? Okay, that is the centripetal force, right? What is centripetal force formula? M, okay, v square divided by radius is r1, mv square by r1. Okay, yes, that is equal to, what is the force that contributes to the centripetal force here? That is the gravitational force in the downward direction, mg in the downward direction, so mg. Not only that, the normal reaction in the opposite direction, right? Normal reaction also in the opposite direction. What is the normal reaction? So let us take this as, okay, that is only given as minus normal reaction at the point A, so that is Na. Okay, so this is the total force in the vertical direction, so that is the centripetal force, so that's it. Okay, so this will give you our required normal reaction. Okay, so this gives the normal reaction, Na equals, so what is that? It is mg, okay, minus mv square divided by r1. Okay, we got Na. Similarly, we will find Nb, normal reaction at the point B. So at the point B, so now we can use the same formula, m v square, because the speed is same, we are using the same v only. That equals, what are the forces acting towards the center? That means upwards, right? In the vertically upward direction. So normal reaction, Na, Nb, upward direction, and minus mg, because mg is actually downward direction, so we have to take its upward value, so minus mg, so minus mg. So this gives you Nb here, so that will give you the value of Nb, so that equals mv square by r2 plus mg. Okay, so that's it. Now this is at the point B. Similarly, at the point C, we will calculate. There is no centripetal force or anything here because there is no circular path. Here you see, it is just a straight line path. So we can simply find the total forces acting in the vertical direction, that is 0, because the object is moving in this direction, so no vertical motion. So total force in the vertical direction is 0. So that means, so Nc, that balances the gravitational force in the downward direction. So Nc must be equal to mg. Now we have got all these values, Na, Nb, Nc. Now we have to compare and tell me which one is bigger, okay, among these three. So this is mg minus something, so it is less than mg, so that is smaller than Nc. Okay, done. Now this is mg plus something, so that is definitely bigger than this mg, so that means, so the biggest value is this one, right? Mg plus something. and similarly this is the next value, right, mg, and this is smaller than that. Okay, so that's all. And but r1 is less than, r1 is bigger than r2, but we don't need to use that. Actually r1 is bigger than r2, so if required we can use it, but here it is not required because here minus, subtraction. So but here we are addition, so this value becomes bigger than mg, this value is smaller than mg. So comparing all this, so we can conclude that, so the smallest value is this one, minus mg minus, that is na. The next value is nc, so that is less than nc, that is less than, this value is the biggest, that is nb. So that means the normal reaction at the point A is the least. Okay, so the radius of curvature is more, at that point it has the least. Okay, anyway, so next one is C and then B. Okay, so this is the relation between the normal reaction at these 3 points. Okay. Here the cylinder is rotating with speed v, and this block is also rotating with the cylinder. Now it is not slipping because of the frictional force, right? The gravitational force in the downward direction against which we have the frictional force in the upward direction. So these two forces should balance each other. But the centripetal force is not due to the frictional force. The force acting in the horizontal direction is the normal force. The normal force between the wall of the cylinder and that block, that normal force is the centripetal force, because that is the force acting in the horizontal direction towards the center. So normal force is the centripetal force, but the friction should be more than the downward gravitational force. Alright, yes. So that is the condition. So let us do it one by one. So now first of all, what is the downward force? That is mg in the downward direction, vertical direction. So the frictional force, right, the frictional force is balanced by the gravitational force, right, so which means mg must be equal to the frictional force. Okay, yes, but this frictional force must be, okay, less than or equal to the limiting friction, right, because this is the static friction, not the kinetic friction. This is static friction because there is no relative motion between these two objects, so it is a static friction, but static friction should be less than or equal to the limiting friction. Okay, yes, so that means mg must be less than or equal to, what is the limiting friction formula? That is mu multiplied by the normal force, right, mu multiplied by the normal force. Okay, yes, so there is a normal force, so let us use this normal force in the centripetal force here. Let's calculate the centripetal force now. So what is the centripetal force here? That is only due to that normal force, right? Normal force is the centripetal force. That equals the centripetal force formula, that is mv square by r. So mv square divided by the radius, so that is r. Okay, so that's it. So that n can be substituted here, that's all. So if you simplify, yes, so what do you get? So mg is less than or equal to mu normal, but that normal is what we found here, mv square divided by r. Okay, now m cancels. Now what we want to find is v, right? So v is greater than or equal to, okay, v is greater than or equal to, so multiply, now m gets cancelled, so rg divided by m is cancelled, rg divided by mu, that's all. So that is the value of v square. So we want to find the v value, so that means square root of that, that's all. That is the answer, right? V greater than or equal to this value, so that is the minimum value, right? So minimum value, it means because it is always greater than or equal to. So this is the minimum speed with which this system is rotating, so that this block m is not slipping, right? Otherwise it will fall down, right? That's all. So v, minimum speed v is root rg divided by mu. Okay, we are done with the centripetal force. In the next class we will do centrifugal force. Okay.